What's going on, everyone? Caleb here with the Drone Dojo and another exciting video.
Here we go.
So in a previous video, I showed you how you could connect a Pixhawk with a Raspberry Pi. You slam them together and you get a Raspberry Pi Pixhawk drone, aka a PiHawk drone. I kind of teased you all the cool things you could do with a Raspberry Pi drone, but didn't go into extreme detail on any particular project. But that changes now. So in this video, we're going to go over one super awesome application. So in this comprehensive video, we're going to cover how you can empower your drone with 4G. So there's a ton of stuff you can do with a 4G connected drone. Maybe you want to upload a video from an autonomous surveillance mission to the cloud. Maybe you want to upload a picture to the cloud and run object recognition on it. I don't know. You get the idea. There's a ton you could do. I could go on and on. One huge benefit of 4G connected drones is your ability to access the drone regardless of your distance or proximity to it. I mean, think about that. That's right. You can interact with your drone from thousands of miles away. As long as it's within range of a cell tower, you can connect with it, interact with it, command it, do whatever you want or need to do. So this video is going to be a comprehensive guide on 4G drones, from the theory, what the heck's going on, to the hardware, how do we set everything up, to the practical applications. And we put this all to the test at the end of the video, where we take a PiHawk drone kit and control it from 70 miles away. Quick note to the FAA, this was not a beyond visual line of sight BVLOS mission. I was remoted into a computer that was 70 miles away and was standing with the drone. Please don't hurt me. Don't find me. Don't hurt me. Anyways, that aside, this video is going to unlock all of the technical aspects of beyond visual line of sight BVLOS control for you. So we're talking limitless telemetry range, we're talking limitless range to SSH into your drone on the Raspberry Pi. You can do a ton of cool stuff, and you're going to understand all the technical aspects of that in this comprehensive video. This video is long enough, so the starting point of this video is to have an already built Raspberry Pi Pixhawk drone, a PiHawk drone, ready to go. I have another video on that shows you how to connect those two. You can check out the blog post or link I have somewhere, I don't know where, but it essentially shows you all the parts you need to build your own Raspberry Pi Pixhawk drone. We also have complete Raspberry Pi drone kits that we offer at the Drone Dojo. If you want the easier solution, it even comes with a video instruction manual on how to put everything together. And you get access to me if you have any questions, but just to let you know, the beginning point of this video is to have an already built Raspberry Pi drone. So with that out of the way, let's get into it. So first thing we're going to look at here, this is our setup to actually get 4G connectivity on our drone. This particular setup is from 6Fab. So this kit will come with the shield that you place on top of the Raspberry Pi, this modem, which will give you internet connectivity. It'll come with this connector, which will connect your hat to the Raspberry Pi, a couple antennas and some jumpers. Now this SIM card will not come with this kit. So you can also get the SIM card from 6Fab's website, but just be aware that you'll have to order this separately. I think it's like $3 or something like that. So I will link to all of this in the description below, so you know where to get that. Next up, we have a couple more hardware components we'll need for our build. We'll look at this first. So this is a UBEC. It basically inputs, I think it'll input from this side actually, inputs 12 volts or a higher voltage supply and outputs a constant 5 volts or 6 volts or 7 volts, whatever you need. We're going to be going with 5 volts on our build. But we need this, and some of you might be saying, my ESCs on my drone supply a constant 5-volt output. Well, the problem is with the ESCs that come with the PiHawk, they output 5 volts at 2 amps, but we need a higher current capacity to power our Raspberry Pi and our 4G Shield. So you'll want a more heavy-duty UBEC that can have a higher current output. This particular one can supply 8 amps continuous at the output, which is good because the recommended amperage current supply for the Pi, I believe, is 3 amps and an additional 3 amps for the 6 fab. So you'll want a heavy-duty UBEC like this. And then how are we going to connect the Pi to this? A couple different ways. What we're going to do in this video is actually we're going to have this USB-C that we're going to connect to the Pi. And then on this end, we're going to just solder in line with our UBEC. So that'll be powering the Pi, and this will be where we will connect that power supply. Then you're going to need some heat shrink. I believe these are 8mm spacers, some helping hands since we're doing soldering iron, and a set of scissors. All right, let's get into it. So the first thing we're going to do is attach this UBEC to our drone. So this side is going to connect to the power distribution board that plugs into the battery, and this side is going to be in line with this connector, which will plug in and power the USB of the Raspberry Pi. So let's look at our drone here. Now we will be needing to remove this top plate in order to do some soldering action here on the power distribution board. So we know the power needs to be hitting here. So I think a good place to mount this UBEC is going to be on the bottom of the drone. All right, so here is the bottom of the drone. So I think a simple but effective way to mount this will be just to put some mounting tape on the back of the UBEC, place it right there, and then we can feed in the side that needs to be soldered to the power distribution board up that slot in the bottom plate. And then these lines we can feed through this slot in the bottom plate. And it'll look something like that. So now we have the output of the UBEC accessing the top, but you know, we're gonna have a lot of extra wire if we don't trim this down. So let's attach the USB-C to the power port of the Raspberry Pi. And we don't want all this extra wire, and we'll trim down the length of the USB-C power. been removed from the top plate, so we can now take it off. Before we do that though, make sure you know the orientation of the drone, because that is informing us where we need to mount our UBEC. So here, our Raspberry Pi, the power side is in the back of the drone, so that is the red legs. The front of the drone is the white legs. All right, so let's take the input to the power distribution board, wire it through that slot on the bottom plate. And make sure you got a little bit of slack there, but again, we don't want these excess wires here because we're going to be soldering to here and here. So if we cut basically maybe halfway up, the UBEC line will have enough slack to still be able to tie into the solder points of this ESC. Let's do what we just did. Let's expose a little bit of that wire. There we go, and let's tin that again. So now let's solder to the power distribution board. It's kind of hard to film and solder at the same time. All right, now that we have that UBEC line soldered onto the power distribution board, let's go ahead and reattach our top plate to the drone. Go ahead and actually fix that UBEC to the bottom frame with some mounting tape. So we're going to want to mount it something like that, and remember this part, the USB-C that's going to the Raspberry Pi is going to slip in through this slot here in the bottom. Do another one by the dust jack. All right, and then you just gotta press down a little bit on there to lock in that mounting tape, and that will be good. So let's flip this over and plug it into the Raspberry Pi. All right, so here is our UBEC power supply, and we'll just be able to plug that right into the Raspberry Pi. Just like that. And we can test to make sure that that UBEC is working properly by plugging in the battery and seeing if we get power to the Raspberry Pi. And you see the lights here right there. Looks like we're good.
Congratulations!
All right, now that we got the power supply all sorted out for our Raspberry Pi and 4G hat, we need to mount the actual 4G shield. So on a typical PiHawk build, you're going to have the Pixhawk mounted directly above the Raspberry Pi. But whenever you want to install the 4G hat from 6Fab, or whoever else you choose to use, it's going to be mounting directly to the Pi, something like that. So you can't have the Pixhawk right on top of the Raspberry Pi. So what we have to do is simply remove this mounting plate that is attaching the Pixhawk, set up our 6Fab 4G hat, and then we're going to mount the Pixhawk on top of the 6Fab hat, and we're going to have some little standoffs here in order to do that. So let's go ahead and get that set up. All right, now let's get that 6Fab 4G LTE hat installed on the Raspberry Pi. First thing we have to do, the 6Fab kit will come with two of these pinout extenders. One is a little longer, so you can still access the pins on the other side of the shield. We're gonna go with the shorter ones here. So just plop that onto the Raspberry Pi pinout. There we go. Now that is installed. Now if you do have a ribbon cable like PiCam camera that you're using on your build, I would suggest that you actually install it on the drone before you situate that 4G hat, because it is possible to install it, but it's pretty dang difficult. So I would just install that now. Once you have that in the slot, the ribbon cable slot, and press down, you should be good to go and continue on with the 4G hat installation. Now you can place our shield on top of the Raspberry Pi. Just press evenly across everything. So next thing we're going to do is install the modem. This is going to actually give us internet access. So these slots will plug in here on the board. So you want to angle it up a little bit like that, and then you'll just press down just like that. And now this modem is secured to the shield. All right, now let's install the antennas here. So you'll notice on here we have 3 little sockets on the modem on our 6-fab shield. So with the first antenna, we have 2 outputs. The GPS output is going to be what we plug in here to the leftmost socket. And then the other antenna will plug into here. So let's go ahead and do that. And it should snap into place. Now we'll do that with the second attachment. There we go. Those 2 are connected now. Let's attach the second antenna. This is white, and that just goes into the rightmost slot or socket. All right, and once those antennas are installed, those flimsy little antennas, we need to mount them onto the drone somewhere. I think the most convenient place is going to be just parallel with the legs here. You do have some 3M sticky tape here on the back if you want to remove that and apply that wherever you want to mount. I actually have some zip ties here on each arm. So I'm just going to actually slip that under the zip ties just in case I choose to, mount them a little more securely in the future. I'll still have that 3M tape. So I'm going to do that on the left side as well. All right, so after we have those antennas secured, let's go ahead and slot in this SIM card so that we can access the mobile networks. And that'll just go in just like that. Now the last thing we have to do is connect the Raspberry Pi to the shield and power it with this cable. So this normal USB will plug into the Raspberry Pi. And then the micro USB just plugs into the hat. And there we go. Our 6-fab 4G hat has been installed to the drone. Now we can mount our Pixhawk on top of this hat and just have a skyscraper of hats for the Raspberry Pi. So we don't want to just mount this directly to the hat. We're going to have our normal Pixhawk mount here. We're going to secure that to the standoffs here with these little guys. I think they're like 8mm standoffs, and those will thread right into the 11mm standoff. So let's go ahead and install these 4. There we go. Now we can install the PiHawk or the Pixhawk mount right on top of those standoffs. Here I have pre-threaded in the screws that will connect to the standoffs. There we go. Have our Pixhawk mount secured. Now we just have to apply some mounting tape and place our Pixhawk on there. right, now we have the Raspberry Pi on the bottom, the 4G mobile connectivity shield in the middle, Pixhawk on top. Now let's just connect everything back to the Pixhawk. So on a typical PiHawk build, you're going to connect the Pixhawk to the Raspberry Pi with this cable. It's going to be a UART connection. But now with this hat we're using, this pinout is no longer really available. But we have another way to connect the Pixhawk to the Raspberry Pi, and that's going to be from the micro USB of the Pixhawk to the normal USB of the Raspberry Pi. Now you can make this connection with any micro USB to USB cable. Just make sure that it is not just a power cable, that you can actually communicate data back and forth. So we're going to install that real quick. I mean, you'll probably want a shorter cord than this. There's surely some on the interwebs somewhere you can get. This was all I had in my room, so I'm going to go ahead and install this unnecessarily long cable. There we go. Now we should be done with the hardware install of our 4G modification to the PiHawk. Hey you. Yes. Talking to your face. If you're liking this video, press the like and the subscribe button, but only with your non-dominant hand, just to really show your appreciation. So let's go ambidextrous on this mission, on this like and subscribe mission. Lefties are righties, righties are lefties. Also leave a comment below about a 4G drone project you are thinking about working on now. What's going on in your head? Back to the video. Alright, so we have the hardware set up on our drone now for 4G connectivity, but the firmware has not been configured to actually use that network interface, so we're not going to actually have 4G internet yet if we were to power up the drone. So in this next step of the video, we're going to set up our firmware to actually use that hat that we just installed. But, so that this video isn't 19 hours long, I'm going to assume you already have a Raspberry Pi up and running that you can SSH into or get access to in some way. If you are not at that step, pause this video, go on over to the YouTube, type in Raspberry Pi drone, and you'll find the best video there ever was. And follow those steps. It's going to show you how to flash the operating system onto the micro SD card, install all the dependencies, SSH into it, and all that fun stuff. So here are the steps we have to take. We've already done the hardware setup. Now we're going to go to connect.sixfab.com. And this is basically like a dashboard to manage different SIM cards and pay your data plan that you signed up for. But you can sign up for an account. I already have one, so I'm going to log in with Google. That'll bring you to this nice interface. So here we're going to go over to SIM and register SIM. Okay, so the SIM ICCID, that is going to be the code that is on your SIM card. It is on the SIM card itself, and also if you ordered from 6Fab, it's going to be directly underneath that barcode. So it's a long number. I'm going to type mine in right now. So this is our unique SIM card code, and now we just have to name it something. I obviously have Buster 1 already set up, so I'm going to name mine Buster 2. Go ahead and hit register. Okay, then after we have set up that SIM, we'll see that in our list of SIM cards. Here's Buster 2 that we just created. So now we're going to hit create device. And then it's going to give us some options here. We have global, we have EMEA, which I believe is Europe, Africa, and Asia, and APAC, which I believe is Asia specific. So I'm going to hit global here. And that's going to give us some code that we have to copy and run on our Raspberry Pi. So go ahead and get access to your Raspberry Pi. I'm going to SSH into my Pi. Okay, and before we run that code, we need to test to see if our internet is properly working. So we're going to say ping 8.8.8.8, and that is Google's name servers, I believe. So if it says destination unreachable, what that likely means is your default gateway on the Pi is trying to use the 4G interface. Let me show you what I mean. Type ifconfig. So here are our 4 network interfaces. The 2 we're worried about right now are WLAN 0 and WWAN 0. WLAN 0 is the wireless network interface that comes standard on a Raspberry Pi. And this is our IP address. Then we have WWAN 0, and this is our 4G interface. What's happening is the default gateway is trying to go through our wireless interface, and that isn't properly set up to connect to the internet yet. So we're trying to communicate with the internet, but nothing's happening because that's not set up. So what we have to do is make a modification to our default gateway. And we'll do that with a, whoops, take two, there we go. We'll do that with a command like this: sudo IP route add default via IP address dev WLAN 0. So what you have to change on your command, everything stays the same except for this right here, 192.168.0.1. So look at your WLAN 0 network interface. Yours might be called something different. And grab the first 3 numbers, so 192.168.0, and then we're going to just add a 1 to the end of that, because that is almost always the gateway. So if yours is 192.168.1.206, then down here you'll do 192.168.1.1. Okay? And then we'll do dev, and then the name of your wireless network interface. So mine is WLAN 0, yours might be something else. Now this is very, very important. Before you run this command that 6Fab gave us, that'll modify our firmware, we have to unplug that micro USB cable from the 6Fab hat. Very important. Unplug the USB cable from the hat. And then, only after you have that unplugged, should you run this command. Once we have that ready to go, we'll copy in that command that we got from 6Fab, and then we'll hit enter, and we'll let it do its magic. All right, now that installation takes maybe about 5 minutes. So after that is done, you can go ahead and plug that USB back into the 6Fab hat, and then we'll hit enter to reboot the Raspberry Pi. All right, then after we're done running that installation code and our Pi is booted back up, go back to SIM list and look at the name of your SIM card, and now it should say device status online. The SIM status should be inactive, so we can fix that by going to show details. And here, just flip the radio button from inactive to active. We already named it. Networks, we're going to stay on low cost networks. Monthly limit, you can go to unlimited if you want. I like to just keep this at 100 megabytes. And the typical charge rate is going to be 10 cents a megabyte. So right here, we're limiting ourselves to $10 a month of data. Now, if you need more than that, obviously you can switch unlimited, but this is kind of just a safety feature. The rest of this stuff, you can keep it how it is, and then we'll hit update. Now the stats, we won't have much stats here because we just turned this on, but over time you'll be able to see data usage and stuff like that. But now we'll go over to device, and here is where there's a lot of cool stuff going on. So connectivity, we see the active interface is our Wi-Fi interface, which is good because Wi-Fi is free, so we're connected to the internet with our Wi-Fi. But available interfaces, we also have the WWAN 0 interface, our cellular interface. So that is active if we need it. And then we can see other things like Linux, what architecture is it, the host name. You'd probably want to change that eventually. And then this is the signal connection. So we have a decent signal connection. This is the really cool part about this area of the dashboard, Open Remote Terminal. So as long as our Raspberry Pi is on, it has the 4G hat on, it's powered up, and we have access to this dashboard, which we can access from anywhere, we could simply click this button, Open Remote Terminal, and it's going to connect to our Raspberry Pi just like that. And we're connected through the 4G internet. So this is really freaking cool, right?
You can say that again.
We can access our drone from wherever we're at. As long as we have internet connection, we're within range of a 4G network for our drone, we can access this. If config, we can do all the normal commands. So that's one really cool feature about this dashboard. We can manage all of our SIM connected devices here under My Sims. We can access a quick remote terminal if we wanted to run something. But, as good as this is, you wouldn't want this to be your primary method of connecting to your mobile network drone. The terminal can be a little bit annoying. Some of the keys don't translate perfectly onto the terminal, and that can be annoying. So throughout the rest of this video, we're going to show you 2 different ways that you can utilize the 4G connectivity in a much simpler fashion. Okay, so now we know how to access the Raspberry Pi through the 6Fab terminal, but that, it's nice, but it requires an internet connection, and it's kind of inconvenient at times if you want to remote into your Raspberry Pi by going onto some internet interface. So what we're going to do now, where am I pointing now, is use something called MAVProxy. And MAVProxy is a command line based ground control station. You should have learned about that and installed that in the Raspberry Pi Pixhawk video that I mentioned earlier. But that is going to allow us to port all of our drone telemetry data to our computer with the ground control station as long as our drone is connected to a mobile network. So it could be 500 miles away, and what I'm going to show you now is going to let you input telemetry data to your computer, and you'll also be able to control the drone from your computer. So that's pretty cool, right? So we're going to jump into that right now. All right, so as I just mentioned, we are going to jump into MAVProxy now. And what is that going to allow us to do? Well, it's going to give us limitless telemetry range with a mobile network. So, normally on a drone setup, you're going to have physical telemetry modules. You'll have one on the computer side that is going to have your ground control station, and you're going to have one drone side. Those typically communicate through the 915 megahertz band in the United States, and most other countries it's 433 megahertz. Now, the problem with this is that this method of receiving telemetry data is limited to range. So the 915 megahertz may only have, a couple miles of range. And if your drone flies out of that, then you're not going to be able to get telemetry data to your computer, which, as we know, is very important, right? Because you can receive data, you can see what's going on with the drone, and you can also control the drone from the ground control station. So it would be very, very helpful if you weren't bound by a particular radius to be able to interact with telemetry. And that's exactly what mobile network telemetry does for us. Now, before we jump into the nitty-gritty on what we have to do, let's just take a quick refresher on what your local home network probably looks like. You're going to have a router here, and that is going to be something like 192.168 or 10.0.0. Those types of IP addresses are reserved for local networks. And your router is going to give IP addresses on that same subnet, but to all the devices. So your phone might be 0.117, your desktop might be 0.125, and so on. So this is just half of the equation, right? So on the other end, our router also has a public IP address. Now, the public IP address is special because it is unique. There is only one IP address like this on the entire internet. Now, the same can't be said for the local IP address, and that's why we use this on local networks, because it can be reused over and over and over again, and it wouldn't interfere with anyone else's internet. So we have our public IP address here, and just to make things simple, we're going to say our router connects with the internet. We're going to black box that. It connects with the internet and communicates with the public IP address. And all the other websites and servers connect to the internet, right? We have Google, that I think one of their IP addresses is this right here. So let's say we're on our computer on our local network. We say we want to go to google.com, so we put that into our router. We communicate with, hey, 192.168.0.1. I want to communicate with Google. And so then that traffic, that request gets forwarded to the public IP address, which connects to the internet, connects to Google. We get the server information, and then it comes back to the internet, back to our router, back to the device that we requested on. So that's kind of like a high-level look at how the internet works. So now we're going to throw in, our drone connected to the mobile network into the picture. So here we have our drone, Buster 2 for me, and it's going to, with that hat that we installed, communicate with the cell towers. The cell towers connect to the internet, and then through the internet we can communicate with any device we want. And any device we want, that could be our computer, where we, instead of forwarding the telemetry data through the physical modules, we forward that through the internet. So it looks something like this. Our drone is communicating data through the cell tower, connects to the internet, connects to our specific router, and then connects to the device that we want to receive coordinates on. And then we would even see our map update with the drone's location. And we could also send commands to the drone after we have this connection established. And we could get it to fly. We could arm the drone, tell it to fly to a particular altitude. So this is what we're going to be setting up right now. We're going to set up MAVProxy to connect the ground control station to the drone. Now, there are some things we have to do. First, we have to find the IP address of the modem. It's modem/router. Then we have to allow something called port forwarding on our router, and I will show you guys how to do that. Then we have to remote into our drone's Raspberry Pi and start MAVProxy. Then we have to start Mission Planner and receive the mobile network telemetry. So let's jump into it. All right, so let's start with the first item on our to-do list. So all we have to do is find the IP address of our modem router. So you are going to go to a site called IP4.me. You're going to go here. I'm not going to do it because it'll show my IP address, and I don't want this video to have my router's IP address shown to the masses, but you're going to go to this site, and it's going to display to you what your IP address is. And make note of that, because we're going to use that later on. So write it down on a piece of paper or write it down somewhere, because in a couple minutes we're going to be using that. So the next thing we have to do is allow port forwarding on our router. So before we do that, I think it makes sense for us to actually understand what we're doing, right? Because instructions without understanding, it's pointless. So let's imagine you're on the east coast of the United States, right? There's a bunch of different bays that you could bring your boat into. Let's say this is Bay A. So we're the captains of our ship. We roll into Bay A. Well, now where the heck are we supposed to dock our boat? This dock, this dock, this dock? We don't know. So we need further instruction on where to park our boat. Once we have the right bay and the right dock, then we can go ahead and safely dock our boat. Well, that same problem is actually present with our IP-based communication. So let's think of the IP address as the bay, and then the port number as the dock. So it gives us specific instructions on where we need our internet traffic to go. So you might not know this, but anytime you go to a website and you're using the HTTPS protocol, you're actually using port 443. And if you're using HTTP, that's port 80, right? So it's telling the internet or your browser to go to a machine, in our case Google, and then at a particular port, 443. Okay, now that we kind of understand ports and their relation to IP addresses, let's jump into why we need to do port forwarding. So our drone is going to be communicating with our router. It's going to mention the IP address of our router. Again, this is not my IP address, but it's going to mention the IP address of our router so that we can communicate with it. And it's also going to be mentioning a particular port. In our situation, we're going to be using port 5000 just because that's a port that isn't used by many programs. So we should be safe to use this port. So our drone's going to try to communicate with our router at port 5000. Now, normally our router is just going to drop this traffic, right? It's going to say, I don't know where this traffic is coming from. It didn't come from a request from me. This is not a familiar port number. So I'm just going to drop the traffic. And there we go. What we call that a firewall. But in our case, we actually want to accept our traffic. So let's say we're on this computer, right? And we want the drone traffic to go to this computer. So what we would do is set up port forwarding. We would say on our router, anytime you receive traffic to the port 5000 or whatever port that you're configuring, anytime you receive traffic to that port number, forward that traffic to a particular machine. Our particular machine is going to be the computer running our ground control station. So that way, our router will receive traffic from our drone. It'll say, hey, this is from port 5000. I've been instructed to forward this traffic to this computer, and we can get a good connection. So now, hopefully you understand a little bit about what port forwarding is. It both lets traffic through to your network and directs it to the ideal computer. Now we're going to show you how to set that up. So it's going to be different depending on what kind of router you have. But if you know your IP address, and it's very simple, if you just pull up a CMD, if you're on Windows, type IP config, you'll see the first 3 digits of your IP address. We call that an octet. So your IP address would be 192.168.0.1. It's typically going to be the first machine or IP number on your subnet. So you would type in 192.168.0.1, and it brings up your router. So in my case, I can also edit my router through the internet. And so I'm just going to jump over here. But anytime you log into your router, you're going to have the ability to edit the settings. So once you're on your router, try to go to the settings editing option, and you should see something called port forwarding. So we're going to click on that, and this is where we're going to set up our port forwarding. So right now, we're going to say add port forward and select the device you want to port forward. So in my case, my computer is this right here, desktop with all this fancy stuff. You might not have this option. You might need to actually find the IP address of your particular device, but in any case, you're going to select your device that you want the traffic to be forwarded to. Okay. Now we're going to select the port number that we want to forward. So ours is going to be 5000. Now mine is already in use because I've already set that up, but go ahead and enter in 5000 here. Keep the TCP UDP. Go ahead and do that, and then hit next. And it's adding a port forward, and there we go. Now we should be able to receive traffic that is hitting our router at that port number. So our destination is going to be remoting into our Raspberry Pi. So we're going to be using MAVProxy. So if you have not done that yet, go ahead and go back to the Raspberry Pi Pixhawk video and go to the installation portion of that video. But we're going to turn our drone on and then remote into it. There we go, log in as Pi. The password is Raspberry. So if we type ifconfig, we should see we have WLAN up and running, and we have WWAN up and running. So now we're going to start MAVProxy. How do we do that? And again, this is going to forward telemetry data to our computer. So let's type MAVProxy.py. That's the command. And then --master. This command is going to be connecting us to the Pixhawk flight controller. And that is, it's connected through a USB cable, which is DTY ACM0. So that command right there is just going to connect us to the Pixhawk that is running Ardupilot. So once we have that connection, we're going to type --out. So what is this? This is going to be the IP address of our router. I'm not going to type mine in here, but it looks something like, it'll have 4 different octets. So let's say that was your IP address. You would type that, then you'd hit a colon. So that's the IP address. After the colon is the port number. You would type the port number 5000, which is what we configured to port forward on our router. And then you would hit enter. Okay, and then after you hit enter, you should have access to, this is a MAVProxy ground control station. It's a command line based ground control station. But the primary reason we're using MAVProxy here is just to forward telemetry data to our computer. So now that stream of data should be hitting our computer now. Now we have to open up Mission Planner. But on the top right, this is how we want to connect to our drone. So normally we choose one of the COM ports, but now we're going to choose UDP. UDP, keep the baud rate at 115200, hit connect. And now we're going to enter in the port we want Mission Planner to listen on. And this is going to be the same port that we were forwarding on, so port 5000. So we'll put that in, and look at that. We are connecting our ground control station to our drone via telemetry, and it's all happening through the mobile network. This is not through the physical telemetry modules. And this is the location of my drone. And it's all happening through the mobile networks. And, you know, I'm right here. It wouldn't matter if this drone was in Wisconsin. It would still work if it was in range of a mobile network. And so this is really, really neat, right? Because you can actually, we're getting data back to our drone. We see the state of the drone, but we could also command it. We could tell the drone to arm, get the props to start spinning. We could tell the drone to take off, and it would fly into the air. We could tell it to fly to a particular waypoint, and it would fly there. So we can control the drone from Mission Planner, and we can get telemetry data back to see its health and stuff like that. So you can imagine how important this would be for things like fleet management. Let's say you have a bunch of drones all over the world, and you need a central place to manage them all. And it can't be bound by your how close you are to the drone. So this is a way to have a limitless range for communicating with your drone. So this last method is one of my favorites. Basically, you know, right from our computer or any computer you're on, you know, you can SSH into other computers. Well, we're going to set up a way to SSH into our drone right from our computer. Now, this is great for, you know, having a reliable terminal on your drone. So think PuTTY or Bash if you have that enabled. It's pretty difficult to set up. So if you're happy with either one of these two methods, you don't have to follow along here. This is going to be just if you want long-term command line level access to your drone. So, and I'll show you why it is a little bit difficult to set up now. So the mobile network interface won't have a public IP address we can access. That is on the Raspberry Pi. It does not have a public IP address. So we need to set up something called a reverse SSH tunnel. Now, thankfully, from the mobile network interface, we can communicate with our home router. which this is not my IP address, it's just it's showcase one, but from knowing our router IP address, we can remote into our computer at home. But, you know, that's kind of useless, right? Because what if the drone's out in the field? Why would we want to remote into our ground control station computer from the Pi? That's reversed, right? We want to be able to SSH into the drone from our computer. Well, that's what you have to do when you don't know the IP address of the Raspberry Pi. That's the reverse SSH tunnel aspect of this. See, we don't know the IP address of the Pi, so what do we do to work around that? We SSH into our computer and establish a connection, and that connection might not even be used immediately. It's just there waiting in the background. And then, since we have that connection from our computer now, we can remote into the drone whenever we want. We don't even need to know the IP address. And we can also set up the initial part of the reverse SSH tunnel to start automatically, right? So any time the Raspberry Pi turns on, it'll try to make this connection. And that way, whenever we want to remote into the drone, we can do that. So there are a bunch of steps we have to do to configure this. So let's just dive right into it. So the first thing we have to do is, if you're on a Windows computer, we need to enable Ubuntu for Windows. And so you'll just pull up the Windows Store. I'm sure there's a way to do this without Ubuntu on Windows, but if you're that advanced, then you probably don't need to follow this tutorial at all. So you'll just search Ubuntu. I'm using 18.04. So you'll just click on that and install it, and then you'll be good to go. So next step is we need to, after we install Ubuntu on Windows, we need to enable OpenSSH on the desktop. On the desktop that we are going to be using as a ground control station, so my computer. So after you have Ubuntu installed, you would just open that up. And another thing we're going to make note of, whenever you install Ubuntu, you're going to create a username that you will use in this environment. So mine is Caleb Berg. You'll need to keep track of what yours is for steps later on. But what we have to do to get SSH going on our Windows computer is just type sudo apt-get install open SSH server. I need to enter there, enter in your password. Okay, then after that's installed, all you would do to start that is type sudo service SSH start. And then you would start that. So now we can see the status of SSH on our Windows computer. SSHD is running, perfect. Because we're going to need SSH server on our Raspberry Pi and our desktop computer. So that is step 2. Step 3 is a little bit difficult, or maybe not difficult to set up, but conceptually difficult to understand. We need to set up SSH keys for the desktop ground control station, which is my computer, or whatever computer you're using to remote into your drone from, and the Raspberry Pi. Now, normally, when you remote into a Raspberry Pi or anything, you're going to be prompted with a password for the username you're trying to log into. With SSH keys, you don't need to put in a password. Just as long as the key is located in your environment, you'll be able to log in without any password. So basically, we have to do these steps for both our desktop computer and the Raspberry Pi. So what do we do? Let's start on the desktop computer. Just open up an Ubuntu terminal and you'll type SSH -keygen -t RSA. And you would type that, and that would generate a public and private key. Now those are stored in the .ssh directory, and the private key is actually stored on the machine you're remoting from. We need to copy the public key over to the machine we want to remote into, which is the Raspberry Pi. So we would take a look at that public key, id_rsa.pub. So this is the key, this entire thing we need to copy into the Raspberry Pi. So pull up another terminal and log into your Raspberry Pi. So remember, we're trying to place the public key that we just generated into our Raspberry Pi so that we can log in without needing a password. So we would do ls-al, and if there is an SSH directory, we would go into that. If there isn't, just type mkdir.sh, and then you would cd into that. Okay, now what we have to look at is authorized keys. So this is where we're going to paste our public key. We would go sudo vi authorized keys. And I've already pasted my key in, but all you would do is copy on in the public key that we just generated. And then you would save that with :wq, and then you'd want to restart SSH. So on the Pi, you would type sudo systemctl restart SSH. There we go. Okay, so now we have the ability to SSH into the Pi without a password. So we have the private key on the desktop, the public key on the Pi. We need to perform the same operation now in reverse. So we need to do the key generation and store the private key on the Pi and place the public key on the desktop. So you do the same thing. And this is going to allow us to SSH into our desktop computer from the Pi, which is crucial. So again, SSH-keygen -t RSA. That would produce private and public key pairings. You don't need to do anything with the private key. You just go into the .ssh directory and look at the public key here. And then, just like we did, only in reverse, we're going to copy this public key and we will place it in the authorized keys of our desktop. So same thing. Sudo vi authorized keys. And we would paste that in. Now, again, you would save that with :wq. All right, and then once we have both of the sets of SSH keys set up so that we can log into the Pi from our desktop without a password, and from the Pi we can log into the desktop without a password, it's time to move on to the next step, and that is changing the default SSH port of the desktop computer to 5000. So it's very simple to do. Normally the SSH port is going to be 22, but we want to change that to 5000 for reasons I will go over in a second. So on your desktop computer, or the computer you're going to be remoting from, you'll just type sudo vi. We're going to edit the sshd config file. And very simple to do, assuming you type your password in correctly. You're just going to find the place in this file where it says port. Now yours might be commented out like this, but you're going to change the port. Yours will say 22 to 5000. And then you'll save that. Then you restart the service here on a Windows Ubuntu, or a Windows machine running an Ubuntu terminal. You type sudo service, I believe SSH restart. There we go. Now the default port on our desktop computer for SSH traffic is 5000. Now, as for the reason why we want to change the default port from 22 to 5000, well, it's because we need to port forward traffic to our desktop computer. And the problem is everyone in the world that can hack something knows that port 22 is going to be the SSH port. So if they see that port's open, they're going to try like crazy to try to SSH into it. So if you change the port number, it won't totally protect your computer, but it's less obvious that that's the SSH port. So now we're going to move on to the next step. We're going to add the new port forward 2222 on the router. So you just do that the same way. We've already covered that, right? So we should have 2 open ports that aren't used. They don't necessarily have to be these 2 ports, just 2 ports that aren't in use. Then, once we have all of that stuff set up correctly, it's time to actually activate the reverse SSH tunnel. Dun, dun, dun. Okay, so how do you do that? It's with this fancy command right here. So open up a desktop terminal and your Raspberry Pi terminal. And on the Raspberry Pi side, we're going to enter in this command. So what is going on here? So essentially, we're typing SSH, bunch of options, and the 2222 is going to be the port on the desktop that we're going to use to access the Raspberry Pi. And I'll show you that in a sec. Port 22 is what port the Raspberry Pi is going to be listening to see SSH traffic. So port 22, that's standard. Caleb Berg is going to be the username of the ground control station computer, or your desktop that you're going to be SSHing from. And then this is going to be the IP address of your router. And then -P5000, that is the port on your desktop computer that is going to be listening to SSH traffic. So we have to stipulate that that is going to be port 5000. And again, we run this command on the Raspberry Pi side. And then, just a quick refresher on the reverse SSH tunnel, once we have that first connection, which is going to be what that command that we just went over is, then we will, whenever we want, be able to SSH into the drone without needing to know the IP address. Let's run that command on the Raspberry Pi side. So pull up your Raspberry Pi terminal, and we're just going to paste, oops, no we're not. We're going to type this command, SSH -F -N, and these are going to be case sensitive, right? So make sure that is all set up appropriately. Now I'm going to get this off screen a little bit because now I have to actually type in the IP address of my router, and I don't want that to be on the internet on a hopefully super successful video. So okay, then once you have that typed on the Raspberry Pi, go ahead and hit enter. And then right after you hit enter, it should return you to the terminal. If it's not immediately returning you here and it's sort of waiting, that means that there's probably something set up incorrectly. But as long as that returns relatively quickly, then you're good to move on. If it doesn't, review the steps that we just went over and see if you're missing something. But once we have entered this command in, we have accomplished the first half of the reverse SSH tunnel. So now our drone has established a connection with our computer. All right, now on the desktop computer, how do we SSH into the drone without knowing the IP address? We type SSH pi at localhost, and then the port number. Remember, this is 2222 for us. So we're going to hit enter here, and it should give us, here we go, access to the drone, the Raspberry Pi, without needing to know the IP address. So that's pretty cool, right? All right, now we know how to start that reverse SSH tunnel and then SSH in from the desktop. But there's one thing missing from our plan because we had to start the reverse SSH tunnel manually. And that meant we already needed to have access to the Raspberry Pi. But in the real world, we're not going to already have access to the Pi. We're going to need the Pi to automatically kick off that process for us. So now we're going to set up that on our Raspberry Pi. So every time it boots up, it'll automatically initiate the reverse SSH tunnel. So there's a couple steps we have to do here, but I actually wrote some scripts for you that you can easily download that'll make this process easier. To get access to those, we'll just type git clone, not cline. You're going to want to type clone, github.com, Drone Dojo, PyDrone scripts. Hit enter there, and you might need to install Git if you don't already have it, but that will download the PyDrone scripts repository. So let's go into there, and then let's go into 4G drone. And we should have 2 scripts in here. Let's make both of those executable by typing chmod +x asterisk. There we go. So we have reverse SSH and we have set IP table.sh. So let's start with the reverse SSH. So there's only one modification, or 2 modifications you'll need to make to this file. Now, this script, I'm going to walk through it sort of from a high level. But here, this is one thing you'll have to change, the home router IP. This is not my IP address, obviously, but whatever your home router IP address is, you'll put that in here. Whatever that is, put that here. Then the other thing you have to change is right here. Okay. Whatever your username on your desktop is, you will enter that here. Instead of Caleb Berg, that'll be your username. So let's walk through the script. So while true, we're going to run through this loop. And this command here, it's going to grab the IP address of the mobile interface. And we need to do this because that mobile interface IP address is going to change from time to time. Right now, WWAN is set at 192.168.225.31, but if you reboot this a couple times, couple days go by, that might change. Just yesterday, mine was .32, so we don't want to put in a static IP address, but we want to grab the interface name and then grab the IP address there. And that is what this command here is doing for us. So let me show you what that command is doing. We're first typing ifconfig, and then we are grepping the interface name, WWAN2. And -A2 means take 2 lines after we find WWAN2 in the command. So before it was a bunch of text, now we're getting WWAN2. Now we're trying to isolate this IP address. So then what we can say is just find the line where it says inet, but we can't just find inet. We need to find inet and then a space, because right here we have inet 6. So we'll type find the line that has an inet and a space. Now we have just that one line. Okay, now each one of these items is separated by a space. So we can use a command called awk, and this is the delimiter between the fields. We're just going to put a space here, and then we want to print out the second column, which is our IP address. And we hit enter, and there we go. So this whole command is going to get us the IP address for this interface name. So that's what we're doing in the script. If we go into reverse SSH, we're running this command, and that's going to give us the script. The reason why we have this in a loop is because we're running this at boot up. So by the time we're running this, ifconfig might not be ready to run. So we're essentially saying, run this command over and over until we find an IP address. So that'll be this point here. If this variable is not empty, then we'll have an IP address. If we have an IP address, then we can initiate the reverse SSH tunnel. And so we'll do this command that we already ran with one modification, with -b. So -b is allowing us to stipulate an IP address we want to do the reverse SSH tunnel from. So we want to do that with the IP address associated with the mobile interface, not our Wi-Fi interface. So that's why we're fetching the IP address for our 4G interface here. We're going to feed that into the reverse tunnel here. And again, change Caleb Berg to whatever the username of your machine is that you're trying to reverse SSH into. And then here, if this command is successful, then break out of the while loop and the script is done. If the SSH was not successful, then we're going to print out initiate SSH tunnel failed, try again. And it'll just go start from the top of the while loop. But once we have that connection established, we'll enter out of the script, and we should have a reverse SSH tunnel waiting for us. Now this other script here that we need to configure, set IP table. Let's go in there and make some modifications. The only thing you have to change here is your home router IP address. That's the only thing. The rest of the stuff will work for you. This is going to add a routing rule to our Raspberry Pi. So essentially, the rule is going to be, if we're trying to access the home router, our home router IP address, let's use the mobile interface. Let's use the WWAN 0 right here. We don't want to use WLAN 0. Okay. So after we run set IP table, we'll see that rule. We'll type route -n, and here we go. If the destination is this 123 whatever, your home router IP address, then use this gateway. This is the gateway associated with your mobile interface. Okay? And we need to do that because when we're out in the field, the default gateway is going to try to be used. But that's not going to work. So we need to establish a new rule. So then once we have an understanding of those two scripts, we need these to run at the boot up on our Raspberry Pi. So how do we do that? Well, let's make note of this. Let's make note of this directory we're in. Okay, and the name's reverse SSH set IP table. So how do we run this at boot up? Very easy. We'll type sudo crontab -e, and then we'll go to the bottom of the file, and we'll say at reboot run, or let's say paste in the script name that we want to run. So we first want to run set IP table.sh, and then we want to run the other script, reverse ssh.sh. Okay, so every time we reboot, these two scripts will get started for us. So we don't have to manually enter these to start the reverse SSH tunnel. There's one more thing we should do. In front here of the set IP table, we'll type sleep 20 with 2 ampersands. And this is just going to say sleep for 20 seconds and then run this command. And then we'll say on the other one, sleep 30, 2 ampersands, and then run this command. And then once we have that, we'll save this file. All right, then once we have put those two files into crontab and we have put in our home router IP address and the username of your computer that you're going to be SSH into, we'll type sudo reboot and we'll see if this worked. So we'll need to let some time pass, but after maybe a minute or so, we can test to see if our reverse SSH tunnel automatically started by running that command again, ssh pi at localhost with the port being 2222. And again, I'm from my desktop computer right now, so if I hit enter, this should log us into the Pi. Here we go. We're logged into the Pi now, and this is over the mobile network interface, not our Wi-Fi interface. So now, in theory, we should be able to remote into our drone regardless of where it is. And every single time the drone reboots, it'll reboot the Raspberry Pi. This command will be initiated, which will automatically start the SSH tunnel to our ground control station computer, and we'll have access to the Pi. It can be anywhere in the world as long as it is connected to the mobile network. We can control it. All right, so now we have that reverse SSH tunnel all configured and we know how to do it. So we're done with the video, right? No, it's project time. Okay, so the mission. We are going to remote into the drone from our desktop computer that we set up to receive the reverse SSH tunnel from. So we're going to have that desktop computer there, and then 70 miles away, we're going to have the drone. So here in the red, we're going to be driving to the Bridge McDonald's, the world famous Bridge McDonald's. And our drone's going to be there, and our desktop, the one we configured with reverse SSH, will be here in yellow. And the mission's going to be very simple. Like I said, we're going to SSH into the drone from our desktop computer. Then once we have that SSH terminal, we're going to run a simple Python drone kit script. It's an autonomous mini mission. It's just going to take the drone off into the air at 1 meter and then land. I've already covered this code in a previous video. Look through my videos for this thumbnail. You can get an idea of the code. But one quick note. So since I need to be within visual line of sight, so I'm not doing BVLOS type missions, I'm actually going to be at the red waypoint. I'm going to be there with the drone, but the computer I want to be using is 70 miles away. So from the drone waypoint, I'm going to remote into my desktop computer with a laptop using TeamViewer, and then essentially I'll be controlling the drone from my desktop. So effectively it's as if I was only at the desktop location, but just to not have the FAA go after me and be legal, I'm going to be with the drone at all times. So with that said, let's get into it. Okay, it is 10 p.m. on a Sunday. I couldn't wait. I'm going to do the mission where I control Buster from 100 miles away. Here he is over here. What's up, Bust? Bust a rhyme. But before we do that, you know, got to fuel up with a little bit of Wendy's. You know, get some spicy chicken sandwiches, and then we'll hit the road. Can I get 2 spicy chicken sandwiches?
What else for you?
Just that. What you want to listen to, Buster? Oh, Poison? Me out of my mind. It's
Six and a half hours later.
All right, here we are, 70 miles away. We got Buster the drone here from one of our PiHawk drone kits, and we're gonna run a simple mission. So we have our laptop, and from this laptop we're going to access the desktop computer that is 70 miles away. And from that desktop, we're going to control the drone. We're gonna run a simple mission to take off into the air and land autonomously. It's only gonna go about a foot or 3 feet, about 1 meter. We have, of course, leashed Buster because we may or may not be in a busy parking lot at 11 p.m. at night on a Sunday. So we have him leashed to about 10 pounds, which Buster cannot fly away with unless he's been doing some gym time. So we're gonna go ahead and remote into the desktop computer so that we can control the drone. Let's also power up the drone so that we can initiate that reverse SSH connection. Okay. So now we're going to remote into the desktop computer. So, you know, I'm out here 70 miles away with Buster, but essentially here I am on my desktop computer now. So let's see if that reverse SSH tunnel successfully was set up. I really hope so, or else I drove 70 miles for nothing. So again, we're going to type SSH pi at localhost, and then we set up port 2222 to be our reverse SSH tunnel port. So we'll hit enter there and pray to God that it lets me get into Buster. Oh my goodness. Oh my goodness. Please, Buster.
Calm down.
Please, Buster. A lot of people watching me right now, Buster. It's a little uncomfortable. Okay, gotta try again. Sweet mother. Okay, there we go. We are remoted into Buster from my desktop computer, which is 70 miles away. Just to prove that to you, we'll type ifconfig, and we don't have a IP address for the Wi-Fi. We are purely connected via mobile networks right now. So now we're going to run a script. We're going to go to PyDrone scripts, DK for drone kit. We're going to run takeoff and land. Now this script is just going to take off into the air at a meter. Target altitude is a meter. And it's simply going to land. And we're going to trigger this script from 70 miles away and watch and see what happens. All right, we hit enter there. Buster should enter guided mode any second now. There we go. Buster is armed, flying into the sky, about 1 meter, and he's landing. And we ran that script from 70 miles away. Let's do that one more time, just because that was so pretty. Let's run that one more time. Run the script. Again, we're on the desktop 70 freaking miles away, and hit enter there. And watch Buster soar into the sky from 70 mile away control. And it could be all right. So there we go. So that was successful. I'm gonna play the victory song. All right, Buster. Unborn Buster. Let's get out of here before security calls us.
Just knew you had it in you, Buster. I knew you had it in you, Buster.
Beautiful. Good work, man. Good work. All right, so I'm back from 70 miles away. Gas station security didn't take me in, so I'm good. But that's basically the end of the video. So we covered a ton of material, and now you know how to create a 4G connected drone. You know how to control it. So there's a ton of knowledge here, so you might need to treat this video as a video textbook and just go over each section. Again, this video is based on our PiHawk Raspberry Pi drone kits. So you can get your own drone kit at our website or by clicking a link somewhere, I don't know. The blog post I'm linking will recap all the hardware you need to finish this project. Drone Dojo members will have access to buy the UBEC pre-soldered to the USB-C power cable, and they'll also be able to schedule Zoom calls with me or another Drone Dojo coach if any questions come up. If you found this video to be ridiculously awesomeness to, let's say, the cubic power, do me a huge favor. Conquer the like button, make it your home. Like it and tell it this is your house now. It pays rent to you. Be nice to the subscribe button. It's old and frail, on its way out. But let me know in the comments section below what our next Drone Dojo project should be. And until next time, it's your Drone Dojo sensei signing out.